A design process for digital products. A design process for digital products. If we design and develop digital products in such a way that the people who use them can easily achieve their goals, they will be satisfied, effective, and happy. They will gladly pay for our products and recommend that others do the same, assuming that we can do so in a cost effective manner. This will translate into business success. So, this is um, the core principle of interaction today. Design today is by developing products that meet or satisfy user while at the same time achieving business goals. On the surface, the premise seems obvious: make people happy, and your products will be a success. Why then are so many digital products so difficult and unpleasant to use? Why aren't we all happy and successful when we use them? Why, despite the steady march of faster, cheaper, and more accessible technology, are we still so often frustrated? The answer, in short, is the absence of design as a fundamental and equal part of the product planning and development process. Design, according to industrial designer Victor Papanek, is the conscious and intuitive effort to impose meaningful order. We propose a somewhat more detailed definition of human oriented design activities. Understanding the desires, needs, motivations, and context of people using products, understanding business, technical and domain opportunities, requirements, and constraints. Using this knowledge as a foundation for plans to create products whose form, content, and behavior are useful, usable, and desirable, as well as economically viable and technically feasible. When performed using the appropriate methods, design can thus provide missing human connection in technological products. But most current approaches to the design of digital products don't work as advertised. For example, an informational website should pay particular attention to content, whereas the design of a simple TV remote control may be concerned primarily with form. As discussed in the introduction, interactive digital products are uniquely imbued with complex behavior. So, when we apply design, it will provide the missing connection with technological products. These are actually what we're trying to accomplish in this design video, understanding the desires, needs, motivations, and context of people using the products, understanding business and other needs, using this knowledge as a foundations for plans to create products whose form, content, and behavior are useful, usable, and desirable. So, for example, informational website should pay particular attention to content since their focus is information, while for a simple TV should be concerned to the form, how big their screen is. So, the consequences of poor product behavior. In the early 20 years since the publication of the first edition of About Face, software and interactive digital products have greatly improved. Many companies have begun to focus on serving people's needs with their products and are spending the time and money needed to support the design process. However, many more still fail to do so at their peril. As long as business continue to focus solely on technology and market data while shortchanging design, they will continue to create the kind of products we've all grown to despise. The following sections describe a few of the consequences of creating products that lacking appropriate design and thus ignore users' needs and desires. Digital products are rude. Digital products and software frequently interrogate users, peppering them with a string of terse questions that they are neither inclined nor prepared to answer. Where did you hide that file? Patronizing questions like, are you sure? And did you really want to delete that file? Or did you have some other reason for pressing the delete key? Are equally irritating and demeaning. So this is one of the reasons, and we have discussed that in details in the previous video, uh, is people or digital products are rude. Here, a dialogue. Thanks for sharing. Why didn't the application notify the library? So why did it want to notify the library? Why is it telling us? And what are we okaying anyway? It's not okay that the application failed. Our software-enabled products also fail to act with a basic level of decency. They forget information we tell them and don't do a very good job of anticipating our needs. Even the iPhone, generally the baseline for good user experience on a digital device, doesn't anticipate that someone might not want to be pestered with a random phone call when he is in the middle of a business meeting that is sitting right there in the iPhone's own calendar. Why can't it quietly put a call that isn't from a family member into voicemail? So a lot of things, design problem in this micro interaction uh, could be produced even in the best so and so best base case for user interface like iPhone. Digital products require people to think like computers. In Microsoft Word, if a user wants to rename a document she is editing, she must know that she must either close the document or use the Save As menu command, and remember to delete the file with the old name. These behaviors are inconsistent with how a normal person thinks about renaming something. Rather, they require that a person change her thinking to be more like the way a computer works. Digital products are also often obscure, hiding meaning, intentions, and actions from users. Applications often express themselves in incomprehensible jargon that cannot be fathomed by normal users. What is your SSID? And are sometimes incomprehensible even to expert. Please specify IRQ. So, as we will later see, we should present the interface related to the user mental model, not with implementation model of the developer in the back end. Digital products have sloppy habits. If a 10-year-old boy behaved like some software apps or devices, he'd be sent to his room without supper. This product forget to shut the refrigerator door, leave their shoes in the middle of the floor, and can't remember what you told them only 5 minutes earlier. Software step us out of the main flow, and on the other hand, some products like Dropbox put their dangerous command on its context menu, practically inviting people to lose their work they've uploaded to the cloud for safekeeping. So they have a sloppy habit. So some of them or a lot of them don't remember what we told them just seconds ago or a minute ago. On the other hand, some of the commands are near the seat lever, right? That makes it unusable and lose people's work. Digital products require humans to do the heavy lifting. Computers and their silicon-enabled brethren are purported to be labor-saving devices, but every time we go out into the field to watch real people doing their jobs with the assistance of technology, we are struck by how much work they are forced to do simply to manage the proper operation of software. This work can be anything from manually copying or worse retyping values from one window to another, to attempting often futilely to paste data between applications that otherwise don't speak to each other, to the ubiquitous clicking and pushing and pulling off windows and widgets around the screen, to to access hidden functionality that people use every day to their job. So it requires us to do the heavy lifting instead of the computer doing it for us. And that's the entire purpose of these computers, to make us more productive. Um, so why digital product fails? Instead of planning and executing with a focus on satisfying the needs of the people who use their products, companies end up creating solutions that, while technically advanced, are difficult to use and control. Like mad scientists, they fail because they have not imbued their creations with sufficient humanity. Why is this? What is it about the technology industry as a whole that make it so inept at designing the interactive parts of digital products? What is so broken about the current process of creating software-enabled products that it results in such a mess? There are four main reasons why this is the case. Misplaced priorities on the part of both product management and development teams, ignorance about real users of the product and what their baseline needs are for success, conflicts of interest when development teams are charged with both designing and building the user experience, lack of a design process that permits knowledge about user needs to be gathered, analyzed, and used to drive the development of the end experience. First, misplaced priorities. While marketers are adept at understanding and quantifying a marketplace opportunity, which is a list of requirements, these requirements often have little to do with what users actually need or desire and have more to do with chasing the competition, managing IT resources with to-do lists, and making guesses based on market surveys. What people say they'll buy. Unfortunately, reducing an interactive product to a list of 100 features doesn't lend itself to the kind of graceful orchestration that is required to make complex technology useful. So adding easy to use as a checklist item does nothing to improve the situation. So these market segments that we have discussed in the previous video and the data that the marketer provide us is useful in choosing the right market, but it does not say about the usability and the desire of the people using the product. It does not provide the harmonized solution that could be implemented to allow cross-functional groups to um, implement the feature in the detailed level to satisfy the customer. Also, adding this easy to use as a checklist does nothing to improve the situation, because it does not say anything about the graceful orchestration of those different departments, as we have discussed in the previous video, and later we'll elaborate more. So good developers are focused on solving challenging technical problems, following good engineering practices, and meeting deadlines. They often are given incomplete, myopic, confusing, and sometimes contradictory instructions and are forced to make significant decisions about the user experience with little time or knowledge of how people will actually use their creations. They are also highly reactive to technical constraints. So, engineers are given a contradictory information, incomplete instructions, and myopic and confusing from marketing and business and testing department. So it's the job of designer as well to integrate those developers' understanding with other department and to persuade them to actually implement it. So you also need to know if the constraints provided by engineers are actually a real constraints, because sometimes they are making that up. So that's why these misplaced priorities are the number one problem. The results of poor product vision are, unfortunately, digital products that irritate rather than please, reduce rather than increase productivity, and fail to meet user needs. So here, the evolution of the software development process. The first diagram depicts the earliest days of the software industry, when smart developers dreamed up products and then built and tested them. Inevitably, professional managers were brought in to help facilitate the process by translating market opportunities into product requirements, as depicted in the third diagram. And the industry matured and testing became a discipline in its own right. With the popularization of the graphical user interface, graphic designers were brought in to create icons and other visual elements. The final diagram shows the goal-directed approach to software development, where decisions about a product's capabilities, form, and behavior are made before the expensive and challenging construction phase. So it should be the first in the product development, the design. So these are the history. Before, build, test, and then ship. Initiate, build, test, ship. Then initiate, build, test, then design and ship. Now it should be designed first. So ignorance about real users. So we might know what market segments our users are in, how much money they make, how they like to spend their weekends, and what sorts of cars they buy. We might even have a vague idea of what kind of jobs they have and some of the major tasks they regularly perform. But does any of this tell us how to make them happy? Does it tell us how they will actually use the product we're building? Or we're just relying to miracle of it just click? Does it tell us why they are doing whatever it is they might need our product for? Why they might want to choose our product over our competitors? Or how can we make sure they do? No, it does not. Conflicts of interest. So the market segment does not provide the information required to differentiate us to competitors, because later we will discover that that is the differentiating factor after the manufacturing boom. Conflicts of interest. Because developers' performance is typically judged by their ability to code efficiently and meet incredibly tight deadlines, and they are also quite understandably the people who usually have the final say on what does and doesn't get built. We must not let them design the product, even if they are highly skilled, just as we would never permit the prosecutor in legal trial to also adjudicate the case. We should make sure that the people designing a product are not the same people building it. Lack of design process. Engineering departments follow or should follow rigorous engineering methods that ensure the feasibility and quality of the technology. Similarly, marketing, sales, and other business units follow their own well-established methods for ensuring the commercial viability of new products. What's left out is a repeatable, predictable, and analytical process for ensuring desirability, transforming an understanding of users into products that meet their professional, personal, and emotional needs. So there is a process, rigorous process for engineering. There is also proven process for sales and other business units. What's left out is a repeatable, predictable, and analytical process for ensuring desirability, transforming an understanding of users into products that meet their professional and personal emotional needs. In the worst case, the decisions about what the digital product will do and how it will communicate with users are simply a byproduct of its construction from developers deep in their thoughts of algorithms and code. So that's the worst case scenario. The developers push their implementation to the user, though it may work on industrial, the first boom of industry. It will not work today because users wants to satisfy their goal. They want some things easy to use or a well-designed product that differentiate from competitors. Some companies may have design process such as including expert and customer directly in development, it ignores a serious methodological flow, confusing domain knowledge with design knowledge. As discussed in previous video, uh, you may be able to articulate problems with interactions but cannot visualize that integrates all needs. So you may include expert, but they have a domain knowledge, but they don't have the design knowledge to integrate solution in different departments. So it 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 will help with some company that does that to integrate it with their design process, but that wouldn't necessarily work when designing a product that fits for your company's goal or uniquely fits to your requirements. In addition, customer who purchase a product may not be the same people who use it from day to day. A subtle but important distinction. Finally, experts in a so another complexity with adding a customer. So you may think that an expert or a customer with has a lot of domain knowledge would be better, uh, would be enough for designing. They may not be the same person who buy the product day to day. So they it has a subtle distinction. Finally, experts in a domain may not be able to easily place themselves in the shoes of less expert users when defining task and flow. So for beginners, since we also need to target the beginners for them to eventually become intermediate for the long-term viability of our product and to make a product that lasts, the expert is not suitable or the customer or intermediate user. Imagine a patient who visit his doctor with acute stomach pain. Doctor, he says, it really hurts. I think it's my appendix. You've got to take it out as soon as possible. A responsible physician wouldn't perform surgery based solely on a patient request, even an earnest one. So they may be the domain expert of their issue. The physician wouldn't perform a surgery based on the just opinion. Now, planning and designing product behavior. The planning of complex digital products require significant upfront effort by designers, just as complex physical structures require architects. In the case of architects, that planning involves understanding how the humans occupying the structure live and work, and designing spaces to support and facilitate those behaviors. In the case of digital products, the planning involves understanding how the human using the product live and work, and designing product behavior and form that support and facilitate the human behaviors. So, architect is a classic and old-fashioned proven field. Before they design a building, they need to understand how the humans that live there will work. So they will design that based on that context. It's the same with complex digital products that interacts and facilitate human behavior, human complex interactions. In the early days of industrial manufacturing, engineering and marketing process alone were sufficient to produce desirable products. It didn't take much more than good engineering and reasonable pricing to produce a hammer, diesel engine, or tube of toothpaste that people would readily purchase. As time progressed, manufacturers of consumer products realized that they needed to differentiate their products from functionally identical products made by competitors, so design was introduced as a means to increase user desire for a product. Graphic designers were employed to create more effective packaging and advertising and industrial designers were engaged to create more comfortable, useful, and exciting forms. Now enter the general purpose computer, the first machine capable of almost limitless behavior via software programming. The interesting thing about this complex behavior or interactivity is that it completely alters the nature of the product it touches. Other aspects of an interactive product become marginal. Who pays attention to the block PC tower that sits under your desk? It is the screen, keyboard, and mouse to which users pay attention. And with touchscreen devices like the iPad and its brethren, the only apparent hardware is the interactive surface. So the only apparent is the screen that you are interacting. It's not really the hardware anymore. So it's not really just the hardware, because usually it's concrete or the same for most people. And it's usually for big companies like Apple and Huawei, Oppo, etc. The traditions of design that corporations have relied on to provide a critical pillar of desirability for products don't provide much guidance in the world of interactivity. So, the desirability has been invented after the age in a few years after the early days of industrial manufacturing, to provide a differentiator to the competitor, but those are now gone. It didn't work. It didn't provide guidance in the world of interactivity because it's so complex, different for different people, to different devices, to different time and life stages. Design of behavior is the different kind of problem that requires greater knowledge of context, not just rules of visual composition and brand. So you don't just need to know the visuals, the rules of visual composition and brands. You need to have a greater context as well as different perspectives to within different departments. So it requires an understanding of the user's relationship with the product from before purchase to end of life. Most important is the understanding of how the user wants to use the product, in what ways and what needs. Interaction design isn't merely a matter of aesthetic choice. Rather, it is based on understanding of user and cognitive principles. This is good news because it makes the design of behavior quite amenable to repeatable process of analysis and synthesis. It doesn't mean that the design of behavior can be automated any more than the design of form or content can be automated, but it does mean that a systematic approach is possible. So here, building successful digital products, three major processes need to be followed in tandem to create successful technology products. This book addresses the first and foremost issue: how to create a product people will desire. So here, designer, you have user model, motivation, behavior, attitudes, and aptitudes. For management, it provides the funding, income, expense projection. Technologies, technology model, core technologies, technology build versus buy, and project delivery, sustainable business, user effectiveness, and customer adoption. So here, desirability, capability, and visibility, overall product success. So these are actually the things that determine the product, how long the product lasts. So that's the reason why you see product that stood the test of time, that actually provides those compound effects to users. So to understand the process of goal-directed design, we first need to understand the nature of user goals, the mental models from which they arise, and how they are the key to designing appropriate interactive behavior. Recognizing user goals. So what are user goals? How can we identify them? How do we know that they are real goals? Rather than tasks users are focused to perform by poorly designed tools or business processes, are they the same for all users? Do they change over time? So we will gonna answer this. We have answered a lot of that in the previous video, but these are the key. So we're trying now to boil down the key issues on how we can actually satisfy the customer's goals, making our product satisfying while at the same time achieving our business need. To do that, we need to know their goals. How can we identify them? How do we know that they are real goals rather than tasks users are forced to perform by poorly designed tools or systems that are built upon them? Are they the same for all users? Do they change over time? Etc. We will gonna answer that, or we have answered a lot of that already. But here, we will gonna simplify the answer. So for an account user goals, efficient invoice processing is more likely the goal of the clerk's employer. The clerk probably concentrates on goals like appearing competent at his job and keeping himself engaged with his work while performing routine and repetitive tasks, although he may not verbally or even consciously acknowledge this. So, as you can see, you may think that an accountant goal is performing that routine and repetitive task or like in efficient invoice processing, but that actually more of a goal of his employer, not him. uh, Products design, so as we have discussed in the personas chapter in the previous video, people have this life uh, end goal and experience goal. You have you those The life goal or the long term goal, probably not this repetitive task for the accountant, right? Probably it could be a saving enough money to sustain my goals or to sustain my life indefinitely, uh, or until I find the job that is um, so that will support my goals. So the clerk probably don't want to do this repetitive task all over again. Products designed and built to achieve business goals alone will eventually fail. Users' personal goals need to be addressed. When the design meets the user personal goals, business goals are achieved far more effectively. If you examine most software, their user interfaces fail to meet user goals with alarming frequency. Most of the same software is equally poor at achieving its business purpose. Invoices don't get processed all that well, customers don't get service on time, decisions don't get properly supported. This is no coincidence. Most of these companies focus on implementation model of their developer, which distract them from user needs. So that's the misplaced priorities problem came from. So, but just as you cannot effectively design a building after construction begin or after coding, you cannot easily make an application serve user goals as soon as significant and inflexible code base is in place. Finally, when companies do focus on the users, they tend to pay too much attention to the task users engage in and not enough attention to their goals in performing those tasks. So another thing is that they focus on their tools, that or the how, instead of the why, which is the user goals. So there is a lot of tasks that could be imposed to the user because of how things uh, uh, works, or by letting things the way they are. But there's a lot of opportunity to improve those hows by understanding more of the why, which we have discussed in the previous. So software can be technologically superb and perform each business task with diligence, yet still be a critical and commercial failure. We can't ignore technology or task, but they play only a part in a larger schema that includes designing to meet user goals. So that's the end goal, is meeting actually the user goals. Goals versus tasks and activities. Goals are driven by human motivations. They change very slowly, if at all, over time. Activities and tasks are much more transient because they are based almost entirely on whatever technology is at hand. So activities or tasks that are used to solve those goals change or more transient. It's not like a sovereign that um, it's not like a sovereign app or that really changed like motivations and goals. Design based solely on understanding activities or tasks run the risk of trapping the design in a model imposed by an outmoded technology. So that's why you see a lot of this old technology or what what they call I forgot what they call, but there's a old technology that's still being used in the system today. So those are the tasks. It's not really the goal. Or using a model that meets a corporation's goals without meeting the user's goals. Understanding users' goals can help designers eliminate the tasks and activities that better technology renders unnecessary for humans to perform. So if you understand what's really behind or the wants or the end goal, the life goal and the experience goal of the customer, then you can minimize the task or less providing less to the customer while achieving that goal. The Norman concludes correctly that traditional task-based focus of digital product design has yielded inadequate results. Many developers and usability professionals still approach interface design by asking what the tasks are. Although this may get the job done, it won't produce much more than an incremental improvement. It won't provide a solution that differentiates your product in the market, and very often, it won't really satisfy the user. So Norman already pointed out this issue with software before that focus on tasks to achieve the user goals, like adding more and more features and functions without actually uh, satisfying the user goals. Designing to meet goals in context. Consider an automated call distribution system. The people who use this product are paid based on how many calls they handle. Their most important concern is not ease of learning but the efficiency with which they can route calls and the rapidity with which those calls can be completed. So they have a different motivation because they are they are paid based on the number of calls. So as you can see, uh, ease of learning or making things easy for people is not always valuable or the ultimate goal of the person. Just like how rich could goals is not to allow for income equality because it will uh, make them less powerful. So it's the same with this designing with this technology. But you get the idea. It's not about the task or how efficient it is, but it's the goal. What the customer wants. So ease of learning is also important, however, because it affects employees' happiness and ultimately turnover rate. So both ease and throughput should be considered in the design. So those learning, of course, is important to the rich, but they want to remain as powerful. So the design, that's the design goal, is to balance those desire so that they can achieve tremendous success, right? So that achieve all of the parties' goal. But there's no doubt that throughput is the dominant demand placed on the system by the users. So if necessary, ease of learning should take a backseat. So the most important to the user is actually those throughput. So if you want to have more users and product that is usable by those users, you need to constantly meet those. So if necessary, ease of learning should take a backseat from that goal. It's just a primary persona or primary secondary persona or secondary goal. An application that walks the user through the call routing process step by step each time merely frustrates him after he's learned the ropes. So you may think that you are making it easy for them, but if you really don't know how their cognitive process work, like they uh, only beginner for sometimes, and then after that most of the time they become intermediate, you don't want to bombard them by simpler and simpler uh, process, simpler but more complicated dialog box such as menu. You want to provide them a icons or things that will make them faster and do not have cognitive load, such as this toolbars and palette that merely that won't frustrate them after he's learned the ropes. On the other hand, if the product in question is kiosk in a corporate lobby helping visitors find their way around, ease of use for first-time user is clearly a major goal. So if it's targeted for beginners like a kiosk, of course, the learnability takes the priority. So it's different, it's really different for different contexts like a framework. But now here, we're being clear on this design framework. A general guideline of interaction design that seems to apply particularly well to productivity tools is that good design makes users more effective. So that's the one of the things that do not change with designing, especially for productivity tools, is that instead of usability of learning, is making the user, especially intermediate, be more effective. These guidelines takes into account the universal human goal of not looking stupid, along with more particular goals of business throughput and ease of use that are relevant in most business situations. So these not only achieve those business goals and the human desire not to feel stupid because they want to be intermediate, and then to help them become more productive. So if they are more productive, we achieve our business goals. Therefore, we satisfy business and user requirements. Software that enable users to perform their task without addressing their goals rarely helps them be truly effective. So if you help them perform the task but not really satisfying their goals, you're not really helping them to be effective. Also, you will lose them in just a matter of time. If the task is to enter 5,000 names and addresses into a database, a smoothly functioning data entry application won't satisfy the user nearly as much as an automated system that extracts the name from the invoicing system. So if you have a user that has a task to enter 5,000 names and addresses into a database, a smooth functioning data entry application won't satisfy the user nearly as much as an automated system that extracts the name from the invoicing system. So you may have a smooth data entry, it will not satisfy because it's repetitive. It's 5,000 names. Although it's the user job to focus on her task, it's the designer job to look beyond the task to identify who the most important users are and then to determine what their goals might be and why. That's where the behavior pattern, the goal-directed research, and primary and secondary persona that we have discussed in the previous video is relevant. So implementation models and mental models. The computer industry still make use of the term computer literacy. Pundits talk about how some people have it and some don't. How those who have it will succeed in the information economy, and how those who lack it will inevitably fall between the socio-economic cracks. Computer literacy, however, is really a euphemism for forcing human beings to stretch their thinking to understand the inner workings of application logic. So the people that are all talking about how those people who understand computer will gonna succeed are just excuse into them creating this software that force the user to understand the implementation model instead of making it work based on their models. So, to stretch their thinking to understand the inner workings of application logic rather than having software enabled products to stretch to meet people's usual way of thinking or based on their cognitive mental model. Let's explore what's really going on when people try to use digital products and what the role of design is in translating coded functions into an understandable and pleasurable experience for users. So, here's what happened actually when developer are translating the coded functions into an understandable and pleasurable experience for users. Implementation models, any machine has a mechanism for accomplishing its purpose. A motion picture projector, for example, uses a complicated sequence of intricately moving parts to create its illusion. It shines a very bright light through a translucent miniature image for a fraction of a second. It then blocks the light for a split second while it moves another miniature image into place. Then it unblocks the light again for another moment. It repeats this process with a new image 24 times per second. Software enabled products don't have mechanisms in the sense of moving parts. These are replaced with algorithms and modules of code that communicate with each other. So that's actually how it works in the back end. It's just an algorithms and modules that works in the back end. The representations of how a machine or application actually work has been called the system model by Donald Norman and others. We prepare the term implementation model because it describes the details of how an application is implement, implemented in code. It is much easier to design software that reflects its implementation model. From the developer's perspective, it's perfectly logical to provide a button for every function, a field for every data input. So a button for a function, a field for data input, a page for every transaction step, and a dialog box for every code module. So a code module is a dialog box actually, like just a configuration of a function. But while this adequately reflects the infrastructure of engineering efforts, it does little to provide coherent mechanisms for a user to achieve his goals. Mental models. From the moviegoer's point of view, it's easy to forget the nuance of sprocket holes and light interrupters while watching an absorbing drama. Many moviegoers, in fact, have little idea how the projector works or how this differs from the way a television works. The viewer imagines that the projector merely throws a picture that moves onto the big screen. This is his mental model or conceptual model. People don't need to know all the details of how a complex mechanism actually works in order to use it, so they create a cognitive shorthand for explaining it. This explanation is powerful enough to cover their interactions with it, but doesn't necessarily reflect its actual inner mechanics. For example, many people imagine that when they plug in their vacuum cleaner and blender, the electricity flows like water from the wall into the appliances through the little black tube of the electrical cord. So they imagine that like water that flow from the wall to the appliances through that black tube or cord. This mental model is perfectly adequate for using household appliances. The fact that the implementation model of household electricity invokes nothing resembling a fluid traveling through a tube and that there is a reversal of electrical potential 120 times per second is relevant uh, to the user, although the power company needs to know the details. We tend to ignore the fact that our cell phone doesn't work like a landline phone. Instead, it is actually a radio transceiver that might swap connections between a half dozen different cellular base antennas in the course of a 2-minute call. Knowing this doesn't help us understand how to use the phone. So it's just how the backend works or implementation model works. You actually are sending signal through towers in the backends. Though engineers need to know that, user doesn't need to know that implementation. The discrepancy between implementation and mental model is particularly stark in the case of software applications, where the complexity of implementation can make it nearly impossible for the user to see the big mechanistic connections between his actions and the application's reactions, because it's so complex, the implementation model. You need to understand the network, the database, the Chrome. You need to know how to troubleshoot. You need to know the how the browser work, how Node.js work in the backend, how operating system. So there's a lot of things that you need to know. So when we use our computer to digitally edit sound or create video special effects like morphing, we are bereft of analogy to the mechanical world. So our mental models are necessarily different from the implementation model. So we can't analyze it, and we can't provide analogy on how it works in the actual world, because we don't have a mental model of that in the physical world. So that's why in the previous video we discussed the idiom on how we actually learn that interfaces. Even if the connections were visible, they would remain inscrutable to most people. So, yeah, it will just confuse the user, and it will dramatically increase the complexity of learning the material. So, you will drastically reduce the learnability and usefulness of your product. Striving toward perfection, represented models. The ability to represent the computer as functioning independent of its true action is far more pronounced in software than in any other medium. It allows a clever designer to hide some of the more unsavory facts of how the software really gets the job done. This disconnection between what is implemented and what is offered as explanation gives rise to a third model in the digital world, the designer's represented model. How the designer chooses to represent an application functioning to the user. So here's the implementation, which is how the code is implemented. Represented model, how the designer choose to represent it, and the mental model, what are the actual people expectation or mental model based on their past experiences. A comparison of the implementation model, mental model, and represented model. The way engineers must build software is often a given, dictated by various technical and business constraints. So how the software do that in the back end are determined by the time deadline, the technical constraints, and their of course capabilities. The model of for how the software actually work is called the implementation model. The way users perceive the jobs they need to, etc. So in the world of software, an application represented model and often should be quite different from an application's actual processing structure. For example, an operating system can make a network file server look as though it were a local disk, but it's actually not. It's just a file server. It's different from a disk because that's an entire network file server. The the disk, remember, is just a part of the computer or the server that stores the data for long term. The model does not represent the fact that the physical disk drive may be miles away. So the model, because it's a network file server, or sometimes commonly now it's a cloud, that physical file does not represent that it's actually miles away or in the cloud. So it just shows that it looks in that it is in your disk in your computer. So the concept of the represented model has no widespread counterpart in the mechanical world. So figure 1.4 shows the relationship between the three models. So here, generally, offering a represented model that follows the implementation model too closely significantly reduces the user's ability to learn and use the application. So you don't want your user to become a developer just to use the application. This occurs because the user's mental model of his task usually differ from the software implementation model. One of the designer's most important goals should be to make the represented model match a user's mental model as closely as possible. Therefore, it is critical that designers understand in detail how computers in the back end and how their target users think about the work they do with the software. We tend to form mental models that are simpler than reality. So most of that mental model is actually simpler than what is actually work in the back end or even in the mechanical world, because it helps us reduce things and focus on a few things that really important to us. So in software, we imagine that a spreadsheet scroll new cells into view when we click the scroll bar. Nothing of that sort actually happened. There's no sheet of cells out there but a tightly packed data structure of values. So it's actually data structure in the backend of values with various pointers between them from which the application synthesize a new image to display in real time through pixels. So design principles should be based in user interfaces should be based on user mental models rather than implementation models. So one of the most significant ways in which computers can assist human beings is presenting complex data and operations in a simple, easily understandable form. As a result, user interfaces that are consistent with user mental models are vastly superior to those that are merely reflections of the implementation model. So that's the same principle, because it helps us assist our productivity with our domain knowledge instead of actually making us unproductive. So this is one of the ways we could meet the business goals while also achieving the customers' goals. So in Adobe Photoshop Express on iPad, so people think that users' goals is actually to become or to understand how things works. That may be true for engineers, but most people just want to achieve their goals and tasks. They'd rather be successful than knowledgeable, right? We've discussed that in the previous video. So in Adobe Photoshop Express on the iPad, users can adjust a set of 10 different visual filters, including noise, contrast, exposure, and tint. Instead of offering numeric fields or many banks of controls for entering filter values, the implementation model, the interface, instead show a set of thumbnail images of edited photo, each with a different filter applied. So here you can see the image. So instead of letting the image show how it actually implemented in the backend using this many bank of controls and entering filter values, the designer represented it through image on how actually use the user see it, or based on his mental model. So a user can tap the image that best represents the desired result and can tweak it with a single large slider. The interface more closely follows his mental model because the user, likely an amateur photographer, is thinking in terms of how this photo looks like or based on his mental model that is easy to grasp cognitively, not in terms of abstract numbers such as implemented model, which is hard to grasp and harder to learn. Adobe Photoshop Express for iPad has a great example of software designed to match user mental models. The interface shows a set of thumbnail images of the photo being edited. A user can tap the thumbnail that best represent the desired setting, which can then be tweaked using the single large slider below the photo. The interface follows mental models of photographers who are after a particular look, not a set of abstract numeric numbers. If the represented model for software closely follow users' mental models, it eliminates needless complexity from the user interface by providing a cognitive framework that makes it evident to the user how his goals and needs can be met. Goal-directed interaction reflect user mental models. So that's where goal-oriented design came from. It's about the goals of the people. It represented the model that close to people. It eliminates the needless complexity of how the back end works, essentially minimizing the cognitive load for the customer. That makes it evident to the user how his goals and needs can be met. So now we know the missing link that prevents products from being successful. The next thing we need is a design process. Translate the implementation of features into intuitive and desirable product behaviors that match how people think about performing tasks toward achieving the goals. So so now we know the missing link on how to actually satisfy the user goals while also achieving the business needs. We need to balance those out by either removing tasks that better meet their goals, that removes exercise and cognitive load. So we need to translate or transform that implementation model into intuitive and desirable products behavior that match how people think about performing tasks toward achieving goal. The goal-directed design process, which we describe in the remainder of this chapter and in the remainder of part 1, provides or in the previous video we discussed that already, provides a structure for determining the answers to this question, a structure by which solution based on this information can be systematically achieved. An overview of goal-directed design. Most technology-focused companies don't have an adequate process for product design, if they have a process at all. But even the more enlightened organizations, those that can boast of an established process, come up against some critical issues that result from traditional ways of approaching the problems of research and design. So, in recent years, the business community has come to recognize that user research is necessary to create good products, but the proper nature of that research is still in question in many organizations. Now, we have found the missing link on how to satisfy or fix those misplaced priorities and conflicts of interest. How do we actually know what the user wants? So in the recent years, research has been integrated to, has been found to be essential as a necessary part of creating good product. But we don't actually know how to research properly. So we will discuss how we can actually solve that another missing problem. Quantitative market research and market segmentation are quite useful for selling products, but fall short of providing critical information about how people actually use products, especially products with complex behaviors. So, marketing is useful for selling products, but they fall short for providing critical information on actually how can we actually make a product that lasts that has a complex behavior such as a software in a hardware. A second problem occurs after the results have been analyzed. Most traditional methods don't provide a means of translating research into design solutions. So a second problem occurs after the results have been analyzed. Most traditional methods don't actually provide a means of translating research results into design solutions. So the 100 page of user service that survey data don't easily, would be uh, would not be useful if you don't know how to bridge the gap and put that onto actual design. Now we will solve that problem in later part. So they say even less about how those requirements should be expressed in terms of a meaningful and appropriate interface structure. Design remains a black box. A miracle happens here. So kind of like the developer just think that it's just a politics, a preference, but actually we're gonna clarify that by having this repeatable analytical process. This gap between research results and the ultimate design solution is the result of a process that doesn't connect the dots from user to final product. So that gap between the research and then the ultimate design solution is a result of not having articulate process that connect the dots from the user to the final product. So we will bridge the gap. Bridging the gap, the role of the design in the development process needs to change. We need to start thinking about design in new ways and start thinking differently about how product decisions are made. Design as a product definition. For many developers and managers, what happens. The word stands for what happens in the third process diagram shown in here, a visual facelift of the implementation model. But design, when properly deployed, as in the fourth process here, both identifies user requirements and defines a detailed plan for the behavior and appearance of products. So it does just not get the user requirements uh, from user research, but can also be used to define a detailed plan for the behavior and appearance of the products in the interface. In other words, design provides true product definition based on user goals, business needs, and technology constraints. So this is actually how you provide that creative solution. You balance that with business, user, and technological constraints. Designers as researchers. So if design is to become product definition, designer need to take on broader role than that assumed in traditional practice, particularly when the object in question is complex, interactive systems. One of the problems with the current development process is that roles in the process are over specialized. Researchers perform research and designers perform design. It's the same with full stack web development as well. Sometimes, if you focus only on the back end, you don't know actually how the product connect to the user goal. So you need to have a little bit of understanding as well as the how front end works and how security works for you to create a more integrated solution. So the result of user and market research. One of the problem with current development process is that roles in the process are over specialized. Research perform research and designers perform design. So the results of user and market research are analyzed by the usability and market research and then thrown over the transform to designers or developers. So actually now in 2025, I think it flipped to full stack developer now integrating every this different constraint, user research, design, front end, back end, that allows them to better create an integrated and harmonized solution based on business goals, business user and technical constraints. What's missing in this model is a systematic means of translating and synthesizing the research into design solution. One of the ways to address this problem is for designers to learn to be researchers. So here, market research performed by market analysts and ethnographers. Design of form performed by graphic or GUI and industrial designers. So there's a discrepancy. A problematic design process. Traditionally, research and design have been separated, with each activity handled by specialists. Research, until recently, referred primarily to market research, and design is too often limited to visual design or skin-deep industrial design. More recently, user research has expanded to include qualitative ethnographic data, yet without including designers in the research process. The connection between research data and design solutions remain tenuous at best. So one of the most powerful tools designers offer is empathy, the ability to feel what others are feeling. The direct and extensive exposure to users that proper user research entails immerses designers in the user's world and gets them thinking about users long before they propose solutions. One of the most dangerous practice in product development is isolating designers from the users, because doing so eliminates empathic knowledge. Additionally, it is often difficult for pure researchers to know what user information is really important from a design perspective. This is a satisfactory solution, provided that your team has the time and resources to train your designers fully in these techniques. If not, cross-disciplinary team of designers and dedicated user researchers is appropriate. So we need to the designer to act as a researcher because they provide empathy. So the direct and extensive exposure to users that proper user research entail immerses designer in the user's world and get them thinking about users long before they propose a solution. So remember, they are the one integrating across different departments. So it's essential for them to be included here. So one of the most dangerous in product development is isolating designers from users because it eliminates empathy. Additionally, it is often difficult for pure researchers to know what user information is really important. From a design perspective, this is a satisfactory solution provided that your team has the time and resources to train your designers fully in these techniques, like goal-directed design. If not, a cross-disciplinary team of designers and dedicated user research is appropriate. Between research and blueprint, models, requirements, and frameworks. The other reason, however, is that few methods capture user behaviors in a manner that appropriately directs the definition of a product. So few methods that actually are proven to work from user research to a product, connecting the dots. Rather than providing information about user goals, most methods provide information at the task level, which is the tools or the how instead of the why. This type of information is useful for defining layout, workflow, and translation of functions into interface controls. So designing interface book could be useful for this because it's more focused on those patterns, but it's less useful for defining the basic framework of what a product is and what it does and how it should meet the user's broad needs, their life, the end, and experience goals. Instead, we need an explicit systematic process to bridge the gap between research and design for defining user models, establishing design requirements, and translating those into a high-level interaction framework. So here, research, users, and the domain modeling of users and use context, requirements, definition of user, business, and technical needs. So we will discuss this in the next video. Framework definition of design structure and flow, how we can actually transform that into a form, an actual form, and how would we design that in details. Refinement of behavior of form and content. So it's more about noticing the little details. So until we get to the granular details, support development needs. A process overview. This process can be roughly divided into 6 phases: research, modeling, requirements definition, framework definition, refinement, and support. These phases follow the 5 components activities of interaction design identified by Gillian and Philip: understanding, abstracting, structuring, representing, and detailing, with a greater emphasis on modeling user behaviors and defining system. So here, as we can see, initiate, goal-directed activity, design, build, test, ship. So like in the previous book, there's no like one linear process. It's all interconnected. So first here in goal-directed, it's more clear. Research. You need to find the scope, define the project goals and schedule, and then concerns, objective, timelines, financial constraints, process, milestone from stakeholders, etc. Stakeholder collaboration, capabilities and scoping, document, statement of work. Audit, review existing work and product, the literature, business and marketing plans, branding strategy, market research, product portfolio plans, competitors, relevant technologies. Stakeholder interviews, understand product vision and constraint, product vision, risk, constraints, opportunities, logistic, and users. So the product vision, we will discuss that, like the overall one goal, like we want to do this to this feature so that we could improve this bottom line, etc. Kind of like overall goals of the business. Stakeholders and users, interviews for stakeholders and users. User interviews and observation, understand user needs and behavior, the one that actually using the product. Users, potential users, behavior, attitudes. So primary persona, secondary persona, behavior, attitudes, like behavior pattern that we have discussed in the previous video. Aptitudes, motivations, environments, tools, challenges. Check in, preliminary research findings. So that's where we actually ship. So the shipment of this is document, statement of work. So the actual research document. Modeling, personas, user and customer archetypes. So this is where the modeling is. Modeling of users and content. The persona chapter we've discussed. Patterns in user and customer behavior, attitudes, aptitudes, goals, environments, tools, and challenges. We will get the information as well here. Some of our information here. Other models represent domain factors beyond individual users and customers. So we also need to know the domain or the trainer. So we also got that from goal-oriented design. As you can see, guys, it's interrelated. Workflows among multiple people, environments, artifacts. So you have a workflow among multiple people. You have also environments and artifacts. Check-in, you also have personas. So in this modeling, you also need to model the key paths, some of the key paths that we've discussed in the previous video for the more detailed framework. So you're touching that in persona creation or scenario. Context scenarios. So here is where you are getting more and more detail. Tell stories about ideal user experiences, how the products fits in the persona's life and environment, how it helps them achieve their goals. So we will create a paragraph for that in the next video. It's more like a text-based rather than a physical or wireframe layout. Scenarios and requirements. Requirements describe necessary capabilities of the products, functionals, and data needs. So that's where we will create the functional, like what functions, usually it's in the button, and data, usually it's in the text field. So for For data requirements, you usually have this anything related or adjectives of the object. Uh, for example, timestamp, message, last date received, last date modified, etc. So that's where the functional and data needs, user mental models, design imperatives, product vision, business requirements. So it's about user domain and domain analysis. So we're getting more and more details. So the shipment here is document, user, and domain analysis. Here, design framework elements define manifestation of information and functionality. Information, functions, mechanism, actions, domain, object models. Framework, object, relationship, conceptual groupings, navigation, sequencing, principles, and patterns. So this is where we will apply all the principles we've discussed in the previous video. Remove excise, dialog box, make sure they are in flow. Make sure to use idioms, sketches, storyboards. How the design fits into an ideal sequence of user behaviors and accommodates a variety of likely conditions. So, presentation, design vision. Detailed design, refine and specify details. So this is the design requirement. Appearance, idioms, interface, widgets. Behavior, information, visualization, brand experience, language, storyboard. So this is where the brand attributes, how it should provide a coherent information, how the posture, etc. So document, form, and behavior specification. Check-ins, design refinement. And then lastly, which is the more complex detailed design modification, accommodate new constraints and timeline based on the new research from the customer. Is the interface needs new redesign based on this and this? Maybe we can create a new session for this type of new design, etc. Maintaining conceptual integrity of the design under changing technology constraints. So collaborative design, revision, form, behavior specification. Research, so the research phase employs ethnographic field study techniques, observation, and conceptual interviews to provide qualitative data about potential or actual users of the product. So it provides qualitative data for potential and the actual users. So your main goal here is to find this user, potential and actual. It also includes competitive audits as well as reviews of market research technology, white papers, and brand strategy, literature, etc., stakeholder interview, etc. It includes one-on-one interviews with stakeholder, developer, subject matter expert, and technology expert as suits the particular domain. In business and technical domains, these behavior patterns tend to map into professional roles. So if you're creating a product for this business and technical, it tends to map to professional roles. So you can also use this in the research. For consumer product, they tend to correspond to lifestyle choice. Behavior patterns and the goals associated with them drive the creation of personas in the modeling phase. So the behavior patterns you get from these roles, sometimes also you can use provision persona if you don't have time to do this. But yes, behavior patterns and the goal associated with them drive the creation of personas in modeling phase. Based on this, entirely roles, SMEs, etc. And then you need to balance that to create a more holistic and graceful orchestration solution. Market research helps select and filter valid persona that fit business models. Stakeholder interviews, literature reviews, and product audits deepen the designer's understanding of the domain and elucidate business goals, brand attributes, and technical constraints that the design must support. Modeling, domain models can include information flow and workflow diagrams, user models. So for modeling, personas, workflow model, information flow, user models or personas are detailed composite user archetypes that represent distinct groupings of behaviors, attitudes, aptitudes, goals, motivations observed and identified during research phase. Specified design targets are chosen from the cast of persona. So we need to choose the primary persona through a process of comparing goals and assigning priorities based on how broadly each persona goals encompass the goals of other personas. A process of designating persona types determine how much influence each persona has on the design's eventual form and behavior. A detailed discussion of persona and goal development can be found in previous videos. Requirements definition. So we will discuss this more detail in the next video. For each interface or primary persona, the process of design in the requirements definition phase involves analyzing persona data and functional needs. So the requirements for this primary and secondary, it actually involves in determining their data and functional needs expressed in terms of objects, actions, and contexts, prioritized and informed by persona goals, behaviors, and interactions with other personas in various contexts. So we will discuss that in the later chapters. So it's basically, it starts usually with an object, a person, or and then an action of that person in a specific context. So we will try to balance that with other persona. So this analysis is accomplished through an iteratively refined context scenario. It starts with the D in the left of the persona using the product, describing a high-level product touchpoints, and thereafter successively defining detail at ever-deepening levels. So after that persona, we're gonna define detail in detail levels, such as redesigning the form by creating different session, etc. that would better support that user goal. In addition to this scenario-driven requirements, designers consider the persona skills and physical abilities as well as issues related to the usage environment. So in addition to this scenario, you also need to consider the persona skills, whether intermediate, beginner, and physical abilities, as well as issue related to the user's usage environment and where are they located. So another thing that makes it complicated is more of like a systematic view of things rather than just a context, and also the environment part, because our environment is complex adaptive system, kind of like how this complex interactive behavior works, right? So business goals, desired brand attributes, and technical constraints are also considered and balanced with persona goals and needs. The output of this process is a requirements definition that balances users' business and technical requirements of the design to follow. Framework definition. Interaction design team synthesize an interaction framework by employing two other critical methodological tools in conjunction with context scenarios. The first is set of general interaction design principles that provide guidance in determining appropriate system behavior in a variety of contexts. So in framework definition, where we're actually synthesizing the interaction framework, we're actually employing two other critical methodological tools in conjunction to context scenarios. So this is actually how we the process on how we better achieve the user satisfaction while achieving our business goal. The first is set of general interaction design principles, which we discussed comprehensively in the previous video in mobile, desktop, and other interfaces that provide guidance in determining appropriate system behavior in a variety of contexts, whether it's modal, drawer for mobile phones, etc. The second critical methodological tool is a set of interaction design patterns. is a set of interaction design patterns. So, design patterns that encode general solutions with variation dependent on context to classes of previously analyzed problems. So those are the dialogues and controls. But the principles are like the exercise, the focus principle, the idioms, those are the principles. And accessibility, different needs, etc. These patterns bear close resemblance to the concept of architectural design patterns, first developed by Christopher Alexander and more recently brought to the programming field by Erich Gamma and others. Interaction design patterns, on the other hand, are hierarchically organized and continuously evolve as new contexts arise. Rather than stifling designer creativity, they often provide needed leverage to approach difficult problems with proven design knowledge. So that's where the design patterns such as the that compose design language such as Bootstrap and that provides the proven solution to that already proven problem. So after data and functional needs are described in this high level, they are translated into design elements according to interaction principles and then organized using patterns and principles into design sketches and behavior description. So you need to watch all the previous design principles to apply that pattern if it actually applied to that context or framework. The output of this process is an interaction framework definition, a stable design concept that provides the logical and high-level formal structure for the detail to come. Successive iterations of more narrowly focused scenarios provide this detail in the refinement phase. The approach is often a balance of top-down, pattern-oriented, and design, and bottom-up, principle-oriented design. So whenever you go from bottom to up, it's a principle-oriented design because you're starting from the basics or bottom. So while the approach is often a balance of top-down, which is pattern is more like a detailed from top to bottom, top to down. So here, when working to design a service, we will collaborate with service designer to drop a service map and a blueprint that coordinates touchpoint and experience across channels, both backstage with the services providers and front stage experiences from the user's point of view. So we discussed this in the previous video, so it's a more detailed stage of design where we want to find the most common paths or functions that user takes and then get a service designer that coordinates those touchpoints and experiences across the channels for that main functions with the service providers and front stage experiences from the user's point of view so that we could integrate those solutions in a more harmonious manner. So as soon as an interaction framework begins to emerge, visual interface designers produce several options for visual framework, which is sometimes also called visual language strategy. So as soon as that there's already an interaction, a service point, an industrial design, this is where the visual design comes into rescue by approaching that into coherent visual design. Actually, this is the more refinement phase of visual designer. They also collaborate early in the design to show the limitation to developers, but it still depends on different organization, but they use brand attributes as well as an understanding of the overall interface structure to develop options for typography, color palettes, and visual style. Refinement. The refinement phase similarly to the framework definition phase, but with increasing focus on detail and implementation. So after this, the refinement, the framework, the refinement actually comes after the framework, but with increasing focus on detail and implementation. So in the front end, in the back end, you're now more focused on technical constraints as well as the visual and cognitive load on the front. And interaction designers focus on task coherence using key path scenarios, walkthroughs, and validation scenarios focus on storyboarding paths through the interface in great detail. Visual designers define a system of type, styles and sizes, icons, and other visual elements that provide a compelling experience with clear affordances and visual hierarchy. Industrial designers, when appropriate, finalize materials and work closely with engineers on assembly schemes and other technical issues. The culmination of the refinement phase is the detailed documentation of the design, a form, and a behavior or specification or blueprint delivered in either paper or interactive media form as context dictates. So it could be a prototype or it could be a long document. Development support, even a very well conceived and validated design solution can possibly anticipate every development challenge and technical question. In our practice, we've learned that it's important to be available to answer developers' questions as they arise during construction process. It is often the case that as the development team prioritizes their work and makes trade-offs to meet deadlines, the design must be adjusted, requiring scaled-down design solutions. So you need to scale down the design to meet the technical constraints. If the interaction design team is not available to create these solutions, developers are forced to do this under time constraint, which has the potential to gravely compromise the integrity of the product's design. So the designer needs to understand that side of the developer so that they won't need to have this time constraint limit, which if the designer are not aware, would enormously uh, hinder the design solution to the interface. Goals, not features, are the key to product success. Developers and marketers often use the language of features and functions to discuss products, but reducing products definition to a list of features and functions ignore the real opportunity, orchestrating technological capability to serve human needs and goals. Too often, the features of our product are a patchwork of nifty technological innovations structured around marketing requirements, documents, or organization of the development team, with little attention paid to the overall user experience. The successful interaction designer must remain her focus on user goals amid the pressures and chaos of the product development cycle. User goal must be the basic, the bedrock which interaction design should be practiced. So it should be focused on the users. And then the designer must remain calm in the chaos of this development process, with the battle in business constraints, deadline, etc. The goal-directed process, with its clear rationale for design decisions, makes collaboration with developers and business people easier. It also ensures that the design in question isn't guesswork, the whim of a creative mind, or just a reflection of the team members' personal preferences. So it makes the design a science that all people could agree on because it's well articulated the connection from research to the product interface. So goal-directed design is a powerful tool for answering the most important questions that crop up during the definition and design of a digital product. Who are my users? What are my users trying to accomplish? How do my users think about what they're trying to accomplish? What kind of experiences do my users find appealing and rewarding? How should my product behave? What form should my product take? How will users interact with my product? How can my product's functions be most effectively organized? How will my product introduce itself to first-time users? How can my product put an understandable, appealing, and controllable face on technology? How can my product deal with problems that users encounter? How will my product help infrequent and experienced users understand how to accomplish their goals? How can my product provide sufficient depth and power for expert users? So we have answered that in detail in the previous videos. Now, creative teamwork, we will discuss how we can actually put that into practice in development environment. So in design and business, teams are common, but rarely are they successful or productive. The finer points of teamwork are not commonly thought or communicated. Teams require meeting time and discussion, and they add layers of communication. If you ever work on a highly productive team, you know that working together can produce outcomes that would be very hard and sometimes impossible for a single individual. In software and service development, we need teammates to ensure that the appropriate problems are addressed, ideas flows, solutions are effectively evaluated, and dead ends are quickly recognized. So, this chapter discusses strategies for working together, complementary approaches to product development, and tactics for assembling teams across an organization. Some of the most interesting and important design problems are too big to solve alone, and too often going it alone also can be rather lonely. So, we will gonna discuss how teams helps us evaluate and quickly find us the dead end if the solution is actually a dead end, and then the realization that a highly productive team actually makes us achieve more than we would have otherwise alone. So small focused teams. It's better for us. This entire chapter mainly focused on small focused teams because that's more effective usually for design. But if you're designing for large organization, uh, there's a part here that tackles those as well. The following discussion addressed the team concept at two levels. Core teams are small and focused. Often they are arranged around a specific kind of expertise, such as engineering know-how, creativity, marketing savvy, or business leadership. But they could also be small, cross-functional teams in a startup or a small-scale product organization. So that's our core team. So it's a focus. Often they are arranged around a specific kind of expertise, such as engineering, design, creativity, marketing, etc. But they can also be small, cross-functional teams in a startup. So it could also have marketing, etc. As long as it's small, around 2 to 4. Extended teams are large and sometimes geographically distributed. This can include stakeholders whose work depends on the results of the project but who aren't responsible for the design itself. In almost any product development effort, the extended product team includes separate core teams for at least marketing, design, and engineering. So marketing, design, and engineering are separated at least for this extended teams. So for product development, these are always separated for the extended team. And also, it includes largely all the stakeholders or people that would be highly affected by the success or failure of the project. Effective functional or cross-functional teams do more than divide and conquer when confronting the never-ending queue. They harness the sparky, sometimes chaotic energies of their members in a collaborative effort that we'll call thought partnership. So effective teams actually harness the sparky and sometimes chaotic energies of their members into collaborative effort we will call thought partnership. You can think of a thought partner as an intellectual complement, a collaborator who shares your goals but who comes at problem from a different angle with a different set of skills. So they have different view, kind of like the user mental model and implementation model and representation model. Both Amos and Daniel Kahneman were critical and argumentative, but during the years of the collaboration, neither of them rejected their out of hand anything other said. So the spirit was collaboratively and feisty, but the output was often unclear. So Daniel Kahneman, who wrote Thinking Fast and Slow for Cognitive Principle, actually are one of the promoter of this concept. What did we because in these different views, it allows them to check and evaluate dead ends faster. So often in team meetings, after the meet and then brainstorm, they often ask themselves, what did we decide again? Whose idea won? What do we need to tackle now? Now, teams that blend these approaches make quick progress through complicated problems. In our practice today, we've applied a much different definition and distinction to each of the two approaches. So, teams that actually evaluate and generate ideas are actually provide better result. So, these two approaches in doing that is generation. In generation-based approach, invention is undertaken boundlessly, and outcomes are most successful when people have space to generate freely, think laterally, and explore openly. Synthesis. In a synthesis-based approach, invention is more fruitful when it is guided and focused. So when you're evaluating what's actually possible, but you're putting that energy in a more productive and practical ways, and outcomes are assured only when they address the user need. So generators and synthesizers. A strong generator typically needs a partner of equal strength in synthesis to strike a healthy balance. When working alone, strong generators may zoom in too quickly on an incomplete solution, so it's not evaluated properly to be practical, spend too much time casting about in the muddiness of brainstorm or generating idea. They need a synthesizer to help make decision at the right level at the right times to keep the design moving forward. So they need a designer that will help them at the right level, so at the right feedback at the right time, so they could move forward in their design. So synthesizers initiate dialogue within their teams. Instead of proposing new ideas and solutions, synthesizers ask questions to locate the intent and value within ideas that have already been proposed. As the conversation proceeds, synthesizers seek clarity, expose gaps, and draw connections. So they seek clarity if that's actually possible in every stage in business goal and every type of holistic or systematic constraints. Draw connections. Synthesizer clarity, expose, and draw connection. When working alone, strong synthesizers can struggle to move beyond list making and scenario thinking. So they are focused on how it will be practical in that risk taking and scenario thinking. They need a generator to pull ideas into concrete, connected form. The dialogue between these two balances inspire ideation with evaluation and sense making. So it balance inspires ideation, which is for generators, and evaluation. A generated idea can emerge as a vague inspired idea, and capable synthesis can quickly reveal its inherent value or ensure that dead ends and darlings are quickly recognized and dispatched. So a generated idea could actually be helpful because it actually inspired people. Uh, because it's kind of like the combination of those different constraints that you would apply in new ways that seem inspiring and new. That's why people are glued to it. So in a typical design meeting, the distinction between roles often manifests itself from first moment, as shown in figure 6.2. Instinctively reaches for the marker and heads to the whiteboard when confronted with design problem. So your generator if most frequently found at the whiteboard, marker in hand, synthesizer if formulating questions, scratching chin. When addressing a design problem, you draws a picture, makes list. When considering a design solution, imagines new directions, ask questions. So here another thing, when articulating the experience as a set of concrete ideas, you're a generator. A story with concrete plot and points, synthesizer. When you offer input in the form of invention, your generator. Clarification, synthesizer. Generator. So generators tend to be relentlessly concrete thinkers, whereas the best synthesizers led with storytelling and promoting. Here's a sample discussion from an imaginary project generator. I have an idea for adding something new to the list. Begins drawing the screen on the whiteboard. It's a gesture. When you're in the main list, you pull down and you start to see the control for adding a new thing. It's just an empty field. So synthesizer, great. It might feel sort of hidden though. In Jeff's scenario, he only adds a new thing every few weeks, right? Generator, yeah. Yeah, true, he might forget it's there. Synthesizer, I like the idea of keeping the focus on information rather than UI widgets, though. Generator, how about we show the field with the help text? Add a new thing when this main screen loads. And then the screen snaps up to cover it. So you see it, but then you focus on the list. Synthesizer, I like it. It might get annoying if it happens a bunch of times in the same session, but I think we can come up with some rules that is not apply on the on all sessions. Only when this main screen load and the screen will snap up to cover it, so you see it, but then you still focus on the list and you focus on information. So this is actually how we redesign those new feature and details. So as we discussed in the previous video, this synthesizer should help shape the discussion, gently tightening the depth of the field. The conversation usually begins with a wide-angle discussion of the problem, and from there, drills ever tighter into the details of solution. So they gently tighten or get into the detail. The conversation usually begins with a wide angle with the generator. So as shown in figure 6.4, creative minds often disagree, especially when they're coming at the problem from different direction. Early on, creative partnership. Trust must be established. Generators must take the lead in concept direction. So as you can see, creative people actually often disagree. So it's normal if your teammate are providing deadlines and providing this new information, because they have a different way of looking at the problem, such as implementing and implementing. Take responsibility, generator. Take responsibility for driving the concept direction. Synthesizer, ensuring that concept is coherent and consistent. So I'm more like a synthesizer because I want the concept to be practical. Can easily slip into excessive detail. The generator, the synthesizer, to preemptive analysis. So as the generator generates or driving the concept direction, it could also drive that in a way that provides a lot of details, while synthesizers are analyzing it too early without actually allowing the ideas to pop up. So when the creative balance is off, they fall in the generator fall in love with the solution and defends it to the death, while the synthesizers block an idea or direction before it has a chance to develop. So when the creative balance is perfect, generator freely experiments with ideas and explore variety of solutions, while synthesizer is open to ideas that might seem jarringly contrary to convention, probes for detail, and nurtures their development. So in the detailed design phase, the team often spends the morning working together and then separates to document details as shown in figure 6.5. So after the meeting, generator draws the interactive structure and flow. Synthesizer copy the rationale for decision in a rough schematics and text, and focus on understanding. Generator focus on understanding flow and the implication of design decision. Synthesizer focus on understanding development of a pattern language. In a detailed, so the generator typically opens a drawing tool and begins capturing decision in the form of drawings. The synthesizer captures decisions either in schematics that help explain the flow or in text that explains the rationale. The details that the team documents can be communicated in a variety of ways depending on the team's size and needs. In our practice, we favor frequent, lightweight, and informal notes over formal documentation milestones in this generation process. So getting started with um, thought partnership, finding a partner who generates. Before you begin, clarify the problem you want to solve. Appeal to the generative capabilities of a colleague or friend. I need someone to help kickstart some ideas. If things don't work at first in the meeting, walk up to the board and draw a bad idea. If your partner is a good generator, he or she will leap up and begin by building on the bad idea or offer a counter proposal. Finding a partner who synthesizes. Before you begin, clarify the problem you want to solve. Appeal to the generative capabilities of a colleague or friend. I need someone to help kickstart some. Oh my god, I copied the wrong one. Let's see. Yeah, so before you begin, make sure you're designing for a higher level story or scenario. Uh, this will help give your partner a rubric form to work during the meeting. Appeal to your partner's evaluative capabilities. Can you help me figure out whether this idea is any good? If things don't immediately go well in the meeting, work on the story. Make sure you're both clear on what the user is doing and why. Switching roles on the fly, synthesizers should probe and guide. Generators should explore and ideate. You can swap roles within a meeting, but it's a good idea to make the switch explicit. When a synthesizer comes up with a great idea, he must resist the urge to wrest the marker away from the generator. Instead, he can simply offer to switch roles. Mind if I generate for a bit? Getting unstuck, the 15-minute rule. In our practice, we encourage teams in another designer if the discussion doesn't advance for 15 minutes. So the core team should brief this outsider on simple contextual details, the user, the scenario, and the ideas under consideration. The outsider should in turn probe the designer for rationale. Why is this good? How is this helped? Almost invariably, this simple conversation helps lift the designers out of the details and move beyond the impasse in a matter of minutes. Right sizing core teams. In scaling up excellence, Stanford business professor Robert and Hagi cite numerous examples in which bigger teams actually produce worse outcomes. They call this phenomenon the problem of more. Employees in bigger teams give other less support and help because it was harder to maintain so many social relationships and to coordinate with more people. The key challenges are how to add rules, tools, and people without creating bloat. So the more relationships, the more complex it is. Kind of like the more you test in A/B testing, the more it's hard to find the cause and effect. In our practice at Cooper, we steer clear of bloat by insisting on four things: small teams, clear roles, tight decisions making loops, and minimal work about work. That last phrase describes any activities that are not directly tied to making progress on the core objectives of product development, coming up with great ideas and shaping great products. Status emails and quick non-critical check-ins are examples of small tasks that can accumulate and end up requiring significant effort and coordination. If you're reading this book while you're in a non-essential meeting, you're sinking in the quicksand of work about work. So status emails and quick non-critical check-ins are a critical example of small tasks that accumulates and end up requiring significant effort on coordination, which makes this complexity of this more groove bad. So in a specific numeric terms, a rule of thumb for the right size core team to focus on individual problem is no more than 4 and no fewer than 2. So if you're really solving the right problem, the right interface, the right persona, you don't need more than 4. A minimum of 2 enables rapid evaluation and iteration. Teams with more than 4 members have too much overhead, too many people to please, and too much opportunity to lose momentum because of that distraction for that emails of cross-functional team. Finally, remember that a small team can be nimble only when roles are clear, responsibility for success is shared, and abilities are contemporary. Working across design principles, disciplines, in our practice, it provides structure when any two individual designers are collaborating. So visual designers and interaction designers, two interaction designers, designer and developer, interaction designer and creative led. So people in different creative genres such as visual and interaction could also be collaborating in the same problem. While the practice of user experience design has become more established, practitioners often find themselves in new collaborative situations with creative professionals from many backgrounds. Interaction design. So when designing physical products, interaction designers must work with industrial designers early on to specify the requirements for physical inputs and to understand the behavior impacts of mechanism behind them. Interaction designers cross paths with visual designers throughout the project. In our practice, their collaboration begins early as visual designers guide discussion of the brand and emotive aspects of the experience in discussion with users and the extended team. So you collaborate here early. This is what I'm saying. The visual design and interaction designs must be orchestrated early, and the user researcher as well, which is the designer. Visual interface design. Visual interface designer work emphasize the organizational aspects of the design and how visual cues and affordances communicate behavior to users. So it's actually another type of design. This is the visual designer we have discussed in the previous video. So this designer must closely work closely with interaction designers to understand the priority of information, flow, and functionality in the interface, and to identify and strike the right emotive tone. Visual interface designer focus on how to match the interface visual structure to the logical structure of both the users and mental models and the application's behavior. They are also concerned with communicating application states to users, such as read-only versus editable, and with cognitive issues surrounding user perception of functions, layout, visual hierarchy, figure ground issues, and so on. So they also are concerned with communication the states such as the modal dialog box, read-only versus editable dialog box, and with cognitive issues regarding user perception, the one that we discussed in the previous video, of functions, layout, visual hierarchy, whether they actually understand that information and whether those functions are useful. Visual interface designer must have command of basic visual properties, color, typography, form, and composition, and must know how this can be used to effectively convey affordance, information hierarchy, and mood. Visual interface designers should be aware of brand psychology, know the history of graphic design, and be familiar with current trends. They must know accessibility principles and the science of human perception. So there's a book, Visual Design and Analysis by Tamara. I think that's where this visual designer will probably came from in terms of his or her basics. So visual interface designer also need a fundamental understanding of interface convention, standards, and common idioms with the toolbars, palette, etc. So graphic design, until the last 20 years or so, the discipline of graphic design was dominated by the medium of printed ink as applied to packaging, advertising, environmental graphics, and document design. Talented digitally fluent graphic designer excel at providing rich, aesthetically pleasing, exciting interface. They can create beautiful and approach surfaces for the interface that establish a mood, connection to corporate brand. For them, design is often first about tone, style, and framework that communicates a brand experience, secondarily about legibility and readability of information, and finally about communicating behavior through affordance. And so the more about instinct, uh, the it's not a visual designer. I mean, visual designer are more advanced than this because they're just for the overall brand attributes, framework, etc. That's why we don't have graphic design in the framework conceptualization in the last video. The primary goal of visual information design is to present data in a way that promotes understanding. This is accomplished by controlling the information hierarchy through the use of visual properties such as typography, color, shape, position, and scale, as well as how these attributes change over time. It also includes micro interactions with information displays that expose details or connection to additional information. So it's about the information and how it provides the context. So the micro interactions by Dan Saffer that we discussed in the previous video, and also the book I recommend, is where this visual information design came from. Common application of visual information design include charts, graphs, sparklines, and other means of displaying quantitative information. Edward Tufte has written several seminal books that cover this topic in detail, including the visual display of quantitative information. It is distinguished from information design in that it is less concerned with contents editorial and information architecture issues. Focusing instead on graphical presentation of that information. This skill set is particularly important in designing data intensive application where users spend much of their time with complex content. So the visual data in analysis by Tamara also apply here. Industrial design laid the groundwork for their concepts with competitive analysis and material research. So they analyze the competitors available with that manufacturer of materials. The input mechanism should not be specified before the desired interaction paradigm are known. So you need to know the interaction first before you know that materials or platform. The extended team. So this is the extended team we're talking about earlier. In the following discussion is intended to outline a few simple strategies for integrating design in large-scale product-focused team. It's not intended to be a comprehensive accounting of the best practices in product or service design and development. Very few ideas are truly great. This is why you need timely, candid feedback from capable collaborators, both among your core team and across the extended product team. You need a timely, candid feedback from capable collaborators, both from your core team and then the extended team, which is the marketing, the engineering, etc. This section discusses the frequent major participants within product teams. Emphasis is placed on how and when to collaborate with them so that ideas get the kinds of critics they need at the appropriate time. Areas of responsibility and authority. Designers are never the sole participants in creating a great interactive experience. Within digital product organizations, the expertise of engineers, marketers, and business stakeholders must be interwoven with the product of designer and product creation and evolution. Usability. Usability strengths or usability department strengths and identifying problems, while design strength is identifying solutions. Collaborator works best when this division of labor is maintained. Engineers must have authority over the raw materials and construction process, development platforms, and libraries. For example, along with the relatively difficult ratings and cost of the items in their backlog. The engineering and design team must stay in touch when those items are being prioritized. So the engineering and design must need to work in agile to work while those are being prioritized. Designer must review and react to the implementation of form and behavior, and both teams must evaluate the success or failure of the Overall experience as it developed and tested, designers should rely on engineers to provide guidance on technical constraints and opportunities, as well as the feasibility of proposed design solutions. Marketing is responsible for defining the market opportunity of a set of customer needs, preference, and motivation. This team also eventually must convince customer to purchase the product. To do this, the marketing must have the authority to advocate for the most lucrative or beneficial customer segments. Its member must provide guidance in targeting design research with appropriate users, and the team must have access to the outcomes of the design research that we've discussed. Business leads are responsible for defining the business opportunity because they're also accountable for the product's profitability. This group must drive decision making around where opportunities for differentiation exist and what features and functions must be prioritized across the extended team. To make those decisions, business leads need to receive clear information from other groups: designs research and product definition, marketing research and sales projection, and engineering estimation of the time and cost to create the product. So the business leads need to make those decisions from clear information from those different departments. So as the product vision evolves, each team must continually seek to address its concern. Designers, what are the simplest, most coherent, most delight aspiring mechanisms for crafting the experience? Usability professionals, does the design deliver on its promise of usefulness? Usability and desirability, do users really use the product as assumed in the design? Engineers, how do we deliver experience in a way that is fast, robust, scalable, and extendable? Marketers, how can we inspire adoption? Business leader, where is the most evident overlap of product function and market need? Collaborating with agile developers, we once believed that all design work should be completed before coding begins, but we've come to learn that this is neither desirable nor practical. Clear benefits arise from methodically testing and proving the feasibility of design hypotheses along the way. Agile methods seek to optimize time and energy, reduce waste, and ensure that concepts actually deliver value to users. However, business stakeholders tend to love the idea of agile development because it sounds economical and efficient. Yes, yet business stakeholders often don't realize until much later that building fast means thinking fast, and fast thinking requires a solid foundation of assumptions and expected outcomes from those goal-directed research. If no underlying foundation or shared vision exists for what should be built and tested, agile work is aimless and contrary to promise waste time because it doesn't have a clear definition of users. It doesn't read the literature, so you need to read or think before doing. Developers tend to love agile methods because such methods support more of what they love, coding, and less of what they don't, sitting in meetings, interpreting requirements, documents. When misapplied, however, this way of working can result in heads down, sprinting toward hazily specified destination, resulting in just as many frustrating dead ends as classic waterfall methods. In our experience, agile method is highly successful when core product elements are clearly rendered, widely understood, and implemented so that they can be tested well. Thus, we have found that the primary elements of an experience should be planned, visualized, and discussed before they are built. So these are more applied in the already built organization, because if you're just creating a new company, extensive design effort are needed. Even in a highly iterative process informed planning should precede construction. You must think before you do. This is much messier reality than the neat sequential compartmentalization design and construction, but it can initiate a product dialogue between designers, developers, and business decision makers. The work of designers on an agile team. In an agile context, designer must prioritize and visualize. They can bring clarity and concreteness to desired outcomes and facilitate conversation around what elements must be developed to achieve them, because they have this broad and systemic details about different stakeholders. So they bring clarity on what must be prioritized because they know the persona and the primary user goal in this research. So there can be tension, outright disagreement in how this experience is defined. When people work in agile team, designer must be able to define the critical elements of the user experience while working in concert with developers who may reveal constraints on or obstacles to that definition. So the designer need to articulate the design decision as well as be able to know to work to the developers and to the product managers as well. So this is where the designers bring clarity on different levels of org. Defining the user experience on agile teams at the beginning of a collaborative effort with agile developers, designers will want to quickly assess how much of the experience has already been defined, specified, or implied. So they need to quickly assess how much of the experience has already been defined, specified, or implied. This definition could be explicit in the form of wireframe, created by a lead architect or business stakeholder, or implicit in the form of shaped assumptions about how it will work, the implementation technologies used by developers, and so on. So the designers want to quickly assess this, the limitation provided by the developers and the wireframe already created by lead architect. So in our practice, agile developers can be capable thought partners at this stage. Talented developers think deeply about the infrastructure and connective tissue of interactive products such as the data in the backend, and they bring a healthy perspective on where the true engineering complications lie. In the best cases, they provide useful direction toward the right level to apply design and ensure that the work of design is useful. So they provide a true engineer that does not want to avoid work, provide useful direction toward the right level to apply design and ensure that the work of design is useful and readily implemented. In the worst case, neither developers nor designer understand the value of the other's expertise. So a worst case is that developers or the tech lead implementator and what the designer wants to differentiate to the market or to meet business and user goals in all across departments is not understood, or there's a confusion. Doing the valuable work on agile team is much like doing in other contexts. It always comes down to articulating user goals, context, and flows. It's about understanding what you're trying to achieve, goals, context, and flows, visualizing and iterating the desired experience, and prompting, gathering, and interpreting correctly frequent user feedback. On a agile team, designer must be able to quickly determine where the biggest user experience challenges lie and to ensure that related elements flows are defined before development begins. Incorporating user feedback. This feedback can be highly useful as long as it prompted, gathered, and interpreted appropriately. When you're a designer, it's critical to determine what you want to learn about the user experience during each release of new features or functions. Feedback is an agile context. In an agile context is fast-paced but familiar. Early on, the prompts should be directed toward understanding whether the fundamental user hypothesis is correct. Do the expected users derive the expected value? How well do the primary elements serve them? So early of the feedback, you want to know if the hypothesis is correct. So do the expected users derive the value on that based on that goal assumption? How well do the primary elements serve them with their task? It's also important to look for what is working, independent of what you hope would work. What are people using? Why? It's important to remove the bias and only summarize what's really interpreted correctly based on the limited variables that could prove that what you're A/B testing is correct. As development continues, feedbacks can be more focused. Do the primary elements flow well? How are they accessed? What isn't used? Where do users stumble? What surprises users? So as the development progresses, you can be more focused on details instead of that primary hypothesis in user goals. So establishing a creative culture. Great teams emerge and develop because they're placed in environments, physical and virtual, that nourish them. In our experience, the team's cultural and social dynamics are as important as clarity around roles. So, does the team enjoy working together? Do they have fun together? Do they have compatible schedules, interests, ways of working, sense of humor? A famous recording studio doesn't guarantee a good record, nor does a great producer. These ingredients are important, but those investments are wasted if the session is unproductive. Environmental serendipity. So these are important if it's should be conducive to the environment. A small workplace, an ideal work room announces itself as a place that is friendly to creativity, providing surfaces and tools for sketching, along with room to move around. Nothing kills momentum more often than distraction. So a workroom should block out as much of the outside world as possible. A door is the typical architectural method of achieving this goal, but doors can be rare in open floor plan workspaces. Find a corner, erect barriers, and keep out the rest of the world as you dive deep into a problem. A collaborative code of conduct, the team should agree on how they'll work together. Clarity and trust in one another's role, responsibilities, and work habits are essential. So people needs to agree in a great culture with their roles. Do they trust them in creating this full stack up? Small rituals are the foundation of good teamwork. Meeting start times, duration, breaks, and agendas can seem inconsequential, but small problems can accumulate. Focus must be established together, so turn off your phone and close your laptop. Like a growing pile of dirty dishes in the kitchen sink, minor inattentions can easily overwhelm good intentions. Do your dishes, hold your teammates accountable, and get to work, and avoid that distraction. Space for positive digression. Digression can seem egregious until they deliver you to unexpected insight. So you need to have space for thinking, kind of like space to talk things without expecting anything. When a team is pressed for time, a digression can feel wasteful and sap energy. Teams who are open to digression tend to have more wide-ranging discussion and arrive at a more interesting and more carefully considered solution. The moral, leave some time to stray. That's why designer has a lot of meetings. So paying attention to social dynamic is critical throughout the lifetime of the partnership. When there's conflict within the team, progress slows, quality decreases, and the end result flatters no one. For a design team, a solution of poor quality should be the ultimate bummer. Identifying skill levels in designer leaders must ensure that problems are right-sized to the abilities of the designer in their practices. This requires a keen sense of problem's location, size, and impact before the design work even begins. Apprentices are early career designers who must be matched with mentors to guide their skill development. It can take considerable time and effort to develop the design judgment that allows apprentices to reliably provide solid, sound ideas that truly fit the task, the design problem. In the process of developing these skills, apprentices must be allowed to stretch to solve problems beyond their skill levels, but they need strong support and guidance from senior teammates while doing so. Craftsmen, with time, designers achieve more and more independence as they master their craft. This allows them to take leadership role within a core team and drive a creative vision every day. Many designers spend their entire career at this level, especially if they're less inclined to take on responsibilities of organizational leadership. Leaders possess high levels of design craft, along with willingness and aptitude to provide organizational leadership. In large-scale product companies, a design leader is essential in providing guidance and structure for the design team, advocating for budget and authority, scoping and prioritizing projects, promoting the cause of design, and hiring designers. Progressing up the ladder of design skill comes down to developing design judgment. How quickly can designer recognize the fitness of a solution to its task? and how reliably can she guide a team toward a better solution or a deeper understanding of the problem. Leaders must supplement hard skills in design judgment and mentorship skills in organizational savvy. Not every designer aspires to develop these capabilities, and leadership is by no means the only or most optimal endpoint for highly talented craftsmen. Collaboration is the key. One of the most challenging and chaotic but ultimately rewarding aspects of this hard work is collaborating with the rest of the product and business team. The vertigo caused by these struggles and challenges has motivated us to take a methodical approach. We have found that designers should be able to collaborate with all the other people on the project team whose works impacts the overall user experience. Depending on the project, this may include design strategists, user and market researchers, user documentation writers, packaging designers, and possibly even store and point of sales designers. So these are just possible, not all of that mentioned here. The visual interaction design, it depends on the context. The point of this collaboration is to ensure that all aspects of the user experience are in harmony, and or the triangulation that we've discussed in the previous book. They shouldn't work at cross purposes or use different design language that could ultimately confuse the user or muddy the product's message. So the purpose of this is to have one language in different department that makes it think that it's just a whim or just a political or miracle creation. Ultimately, the successful delivery of a product that meets people's needs requires the careful coordination of the efforts of a large number of people. We've found that to be effective, designers must ultimately assume considerable responsibility for us orchestrating a fine balance between the numerous forces pushing and pulling on a product. So to be effective, designers must take the responsibility of balancing all those requirements to achieve the goal. So the designers are also required to make the collaboration and culture responsible and focus on the overall vision of the business.